Okay, so this right here, x, you have x and y and t. And this describes a curve. It's one of these four curves here in the sketch. And when you have a t is called the parameter. And so to determine which curve this is, and also it's just directional. So t starts at negative pi and ends up at pi. So it's directional. And to figure out what curve it is, what you can do is start with these values of t. So it starts at negative pi. So I'm just going to put negative pi there. Now, if t is negative pi, what is x going to be? Well, that's going to be negative pi plus sine of negative pi. And sine of negative pi is 0. So this is just going to be negative pi. Okay, and y is going to be cosine of negative pi, which was negative 1. Okay, so you have the point negative pi, negative 1 is a point on the graph. Okay, so if you go back to negative pi and negative 1, that's like right there. Okay, that's right there. That's right there. And you can tell already that it's not going to be either of those two. And it's not going to be this one because the negative pi is the starting point. You see this curve goes, this curve has this point as the ending point. So this is the starting point right here. Okay, so that's out because it should have been at the end over there. Okay, and then we can look at other points. So if you can look at other values in here, so negative pi, there's 0 is in this interval. Okay, 0 is between those two. So we could look at what happened with 0. If you put a 0 in here, x is going to be 0, and y is going to be, cosine 0 is 1. And you can see that it goes through 0, 1 right here. And then we could also try pi. If you put a pi in here, you get pi plus sine pi. You're going to get pi. And for y, it's cosine of pi, which is negative 1. Okay, so that gives you the point pi, negative 1 over here. Pi and negative 1 right there. Okay, so you can, and it kind of traces through that curve right there. Okay. This is more of the same right here, except it has a part B to it. So for the first part, we can start off by doing the same sort of thing. Your parameter t, your x value, and your y value. So it goes from negative 3 to 3. So we should start at negative 3. Okay, when t is negative 3, this is going to be 9 minus, that's going to be 7. And when t is here, negative 3, it's going to be 1. Okay, so you have the point 7, 1. Well, it should be the starting point on the graph. Okay, so here's 7, 1. This one is out, and here's 7, 1 also. And 7, 1 is not on that one, so that's out. And again, it should be the starting point, so this should be this one right here. Okay, and then we can do other points just to like double check. So this is going to be negative 2, 4. Yeah, which is right here. It's also right there, but this is going the wrong direction. It's supposed to start here at negative, when t is negative 3 gives you this point. When t is 0 gives you that point. When t is 3, the ending point, then what do you have? 7, and then, but this is going to be 7 here. Okay, so 7, 7, which is over here. Okay, so this is the correct one. That one's out. There's a part B to it, and part B says eliminate the parameter to find a Cartesian equation that represents the curve. Okay, now sometimes you can do this. Sometimes it's really hard. But this case you can. So the idea is to just focus on these two equations and eliminate the parameter. So you have two equations and three variables, x, y, and t. And the idea is to just eliminate your t. So in this particular case, there's a lot of strategies for doing this, but in this particular case, you can solve y equals t plus 4 for t relatively easily, okay? So t is going to be y minus 4, okay? And then I take the other equation and I plug this in for your t, I plug the y minus 4 in for t, and I have this. And there it is right there, okay? And so you can tell that this is a parabola. Also, they also give you the limits. Y goes from 1 to 7. Okay, so because y is t plus 4, so this goes. So if you add 4 to that, you add 4 to that one, you get 1. You add 4 to 3, you get 7. So y goes, and because y is t plus 4. Okay. So actually this curve up here, though, this whole picture right here is only from when t is -3 to t equals 3. So it's just this part. It's just this part of the parabola. This parabola. Okay. So this equation. In other words, this equation is something different than what this is right here. Okay, because two things. Okay, the first thing is that while all of these points are on this curve or on this parabola, the first thing is that these are directional. It starts here and goes up to there. It's direction. There's a direction. And the second thing is it doesn't have anything to the right of 7, to the right of x equals 7. Okay, so whereas this one would continue going on in this horizontal and to the right, this one stops right there. Okay, so let's move along to number 3, unless there's any questions. Any questions about anything? Okay, let's move on to number 3. So here we have another curve. X equals t squared and y equals t to the 5th. And it doesn't give you limits on t for this problem. And usually that's what is needed. So, but I'm going to say -infinity to infinity. Okay, just for just because you have to put, if there doesn't list anything, then maybe you should just take that to be it. I think you should just take that one to be it. Okay, so let's figure out which one of these curves it is. And again, we will start with some points. We're going from -infinity to infinity. You can't really plug -infinity in, so we can plug in maybe -1. Or we can think about what happens when it's -infinity. When t is -infinity, that's going to be infinity. That's going to be -infinity. So it's going to be positive. So it's going to be this curve right here, I think. But let's try -1. That gives you 1, and then -1 to the 5th is -1. So 1. Oh no, that's like right here. Dang. That was a bad point to choose. If you choose 0, then both of those are 0. So that's this point here. And when you choose let's choose like 2. Then x is going to be 2, y is, wait, what am I doing? X is going to be 2 squared is 4, and 2 to the 5th is 32. And so that's 4, yeah, that looks like it could be 32 right there. And so, yeah, and if you put in, like, if you go to infinity, these are going to infinity, so yeah. And if you put in negative infinity, then the y term is going to negative infinity, going down, and so on. So it goes this way, is the first one. Part B, eliminate the parameter to find a Cartesian equation that represents the curve. Okay, let's try that. So part B, okay, so let's take these curves and we'll try to eliminate the parameter. Okay, now x is always positive, but y can be negative, okay? So if we were to solve for y, then because x is always positive, then it might give us some trouble, okay? So let's try to solve this for x, okay? So we know that t is the square root of x. So we know x has got to be positive, nothing that's plus or minus or anything. Oh, wait a minute. No, we don't know that because t could be negative, right? Ooh. So let's see here. Let's start with this one. So y is t squared to the 5/2. Something like that. No, that's not good. Okay. I don't know what my problem is today. I'm not thinking straight. Or just in this moment. This is just momentarily. So x is going to be y to the 2/5. Yeah, that should do it. X is y to the 2/5 because y is t to the 5th. You put a t to the 5th in here. If you put a t to the 5th in here, then then it will cancel. Then the 5th will reduce this to y to t squared. Okay. Okay, let's move on. Get away from that disaster. Number 4. Part A is to eliminate the parameter first. So eliminate the parameter first. And also, again, t is going to be going from negative infinity to infinity because they don't list anything. Okay, so this is interesting because you have x equals e to the t, and then you have y equals e to the negative 3t. So they're in e to the t's. Okay, we're dealing with exponential functions here. Okay, so but if you take this second equation, that's the same as e to the t to the negative 3. Okay, because when exponentially multiplies, so t times negative 3 is negative 3t. But e to the t is x. Okay, so we have y equals, and then x to the negative 3 is 1 over x cubed. Okay, so that one will do it. But we want to find out which curve it is. So let's put a few different values in. if you can try -1. With -1, this is going to be 1 over e, and then y is going to be e cubed. Okay, so you have 1 over e and e cubed. Oh. That's a small number here. 1 over e is about right over here, and then e cubed is pretty big, so it could be this one right here. It's not going to be this one because it's going the wrong direction. And then, yeah, it's not going to be this one because you want to have a point up here somewhere. So it's going to be neither of those. It's got to be this. It's got to be this second one here. And also, the x-axis is going to be a horizontal asymptote, so that eliminates those two. And if you put 0 in, then what's that going to give you? 1 and 1. So 1's got to be on there, which is right here. I guess that would be on there, but this first point doesn't work out. Okay, so it's got to be this first one. Any questions about that? Okay, let's move on to number 5. Okay, x is the tangent squared of theta, y is the secant of theta. Okay, now we know that there's a trigonometric identity involving the tangent and the secant, which is this. Tangent squared theta minus secant squared theta is -1. Okay, so that's a trigonometric identity. But tangent squared is, yeah, you just spelled x. Secant is y is secant theta, so that means that y squared is secant squared, -1. And so if you solve this for x, you get x equals y squared minus 1. Okay, so that's eliminating the parameter in the in these by just looking at those equations. Okay, now you might think, wow, none of these curves looks like the answer. Or maybe this one does, or maybe that one does, who knows? Let's try to figure out which one it is, okay? So for part B, so again, we're going to go, this time theta is the parameter. So let's use some values here. Okay. So it starts at -π/2. So let's start there, -π/2. Okay, tangent of π/2, and tangent of -π/2 is, what is tangent of -π/2? Okay, well, that's a good question. So here's -π/2 is down here. Maybe if I drew this in black. And I have this angle in blue. Okay, so -π/2. Okay, so the tangent is the let's do a slightly less angle. So the tangent would be this over this, right? That over that. And as you're going to here, as you're going down to this here, then this goes to 1, or this goes to 0. So it's like, or negative 1 over 0. So it's negative 1 over 0. So the tangent of negative pi over 2 is negative 1. But then, no, negative infinity. Because it's 1 divided by 0, right? Negative 1 divided by 0. So it's negative infinity. It's going to negative infinity. But the tangent squared is going to be positive infinity. The secant, see, the secant is the hypotenuse divided by the adjacent, right? So it's this 1 over, so it's like this like 1 over 0. So that's also going to infinity. Okay, so that's just great. So you're starting off infinity, infinity. So I guess that's your beginning point. It's not going to be either of these because your beginning point has to be out, and these their beginning points are right here and here, so it's not going to be either of those. Okay, and then let's put a point in the middle, maybe 0. So that would be this angle here. Okay, tangent of 0 is 0. Secant of 0 is 1. Okay, so tangent 0 is 0. And then 0 squared is 0. And then the secant of 0 is, so it's the x value divided by the hypotenuse, and they're both the same, so that's going to be 1. It's also 1 over the cosine, and the cosine of 0 is also 1. So 0, 1 is going to be on the curve. So 0, 1, that's not 0, 1. This is 0, 1 right here. And then if you were to do another point, let's see, pi over 2, then it's going to be like that. So basically, this is weird. It starts out here at infinity. It starts way out here, comes along the curve, hits that point at 0, and then goes back out. So it's part of this parabola. It's just this part of the parabola. So it starts out there, comes in, hits the point, and then goes back out. That's really weird. Okay, so yeah, so it comes in. It goes in first, and then it goes, and then it comes, and then it goes that way. Okay. Any questions about that? Okay, let's move on to the next problem. Number 6. Describe the motion of a particle at the position x, y as t varies in the given interval. Okay, so first of all, let's try to find an equation. We'll just use these guys, these two, to find an equation that in x and y. And if you see things like sines and cosines, then sometimes you can use this right here. You can use that idea right there. And in this case, you can. So like x minus 5 is sine t, if you look at the first equation, okay? And if you look at the second equation, and then you can solve for cosine t, right? So cosine t is y minus 1. Sine t is x minus 5. So you plug this in here, and you plug this in here, and it gives you x minus 5 squared plus y minus 1 squared over 2 squared equals 1. Okay, so you have x minus 5 squared over 1 squared plus y minus 1 squared over 2 squared equals 1. So it's a problem. This is an ellipse. The center is 5. 5, 1. Okay, so the answer to the first one is 5, 1. And as t goes from pi over 2 to 2 pi, the particle starts at, well, you just, to do this part right here, you put the starting point in. Yeah, I don't know why I put it there. This is theta. No, not theta. T. Because the parameter is t. Okay, so when t is pi over 2, this first one is going to be 5 plus sine of pi over 2. Sine of pi over 2 is 1, so that's going to be 6. And then when t is pi over 2, cosine is 0, so that's just going to be 1. So 6, 1. So it starts at the point 6, 1 and moves clockwise 3/4 of the way around ellipse 2. Okay, then when you put 2 pi in, 2 pi gives you, okay, so sine of 2 pi is 0, so that's just going to be 5. And then cosine of 2 pi is 1, so that's going to be 2. 1 plus 2 is 3. So it goes to 5, 3.